Welcome one and all. So in the previous video we have discussed about what is the general form of Bernoulli's differential equation and how to work with that Bernoulli's differential equation, in the sense how can we solve, what is the procedure and all, and how we can convert a Bernoulli's equation into the linear equation. All those things we have discussed. Now in this lecture we will see how to solve a Bernoulli's differential equation with the help of one example. Now the problem is something like this: dy by dx minus y into tan x is equal to sin x into cos square x divided by y square. This is the given problem now. Now we will see how to solve this problem. In the sense, first of all we will check whether this is in the standard form or not. So what is the standard form of a Bernoulli's in y? So it is something like this: dy by dx plus p of x into y is equal to q of x into y power n. So this is the general form of Bernoulli's differential equation. Okay, now if you compare the given equation with this standard form, we have dy by dx. So in place of p of x we have tan x, okay, and in place of q of x we have sin x into cos square x. This is nothing but q of x we have, okay, and this is p of x we have, and in place of y power n, here we have 1 by y square. So this is nothing but in the form of y power n. Now to convert this one into the linear differential equation, first of all what we will do is we multiply this equation. Let us take given equation as some equation 1. So now we will multiply the given equation with the y square so that we can convert this one into linear. So if you multiply equation y with y square, simply just I will write it here in the simplest form. So multiply equation 1 on both sides with y square, then we get, so y square into dy by dx minus y square into y means y cube, we will get y cube into tan x is equal to sin x into cos square x. So this is how the given equation now reduce it to. Now we will replace, you take this one as some equation 2. Now what we will do is, now you replace this y cube with some variable t, because it is not yet completely converted into linear. Okay, now find the derivative. We get 3y square into dy by dx is equal to dt by dx. This is what we get. Now but here we need y square into dy by dx only we need. So this y square into dy by dx from this one now can be written as, we can write it as y square into dy by dx is equal to 1/3 dt by dx. Now you just substitute these two, means this is what the replacement what we have taken in place of y cube is equal to t, and later on how the derivative converts. So now if we just substitute this equation 3 and 4 in equation 2, then we get, all of you just observe this, after replace how it that equation 2 reduces to. So therefore simply here I am writing, therefore by substituting the equations 3 and 4 in equation 2, okay, we get, so what we get is, check it, so y square into this y square into dy by dx can be written as 1/3 dt by dx. So 1/3 dt by dx minus tan x into y cube. Here we have y cube is replaced with t, so tan x into t is equal to, so there is no change in the RHS, it is nothing but sin x into cos square x. Okay, now we just rewrite this one by multiplying with t on 3 on both sides, then that equation now can be written as dt by dx minus 3 tan x into t is equal to sin x into cos square x. Now if you observe, this is nothing but, if you observe now, this equation 5 is nothing but a linear differential equation in t. So that you can mention here So clearly equation 3 is linear in t. So if you want, just once again you check it. This is of the form some dt by dx minus p of x into t is equal to q of x. Once again, this is of the form dt by dx minus p of x. In place of p of x, just like that, what we have, 3 tan x into t is equal to some q of x, means sin x into cos square x. So means this equation 3 is nothing but linear in the variable t. So we know the procedure to how to solve this linear. So for that, now we have to take the integrating factor. So therefore the integrating factor of equation 3 is, so we know the formula as integrating factor is equal to, so e power of integral of what we have, so the coefficient of t, in the sense p of x, that is nothing but 3 tan x dx you can take, so which is nothing but e power 3 into integral of tan x, means log secant x. So e power of 3 log secant x now can be written as, here I will like, so e power log of secant cube x by using the logarithmic formula. Okay, now we have e power log of something we have, so means now this one can be written as secant cube x. So this is the integrating factor. So integrating factor for equation 5, which is nothing but linear in t. So therefore now we can find out its general equation. Okay, so therefore now we can write, therefore the general solution of equation 3, so not equation 3, equation 5 is, I think in the previous also I wrote equation 3 somewhere, so this is not equation 3, equation 5, so this is 5 here, therefore we take. Now the equation 5 is, so actually have to write a t y into, but here the dependent variable is t, so t into integrating factor is equal to integral of integrating factor into, so in place of q here what we have, so in the equation in place of q we have sin x into cos square x, that one only now we write it. So sin x into cos square x whole into dx, because here x is the dependent variable and t is the, sorry, x is the independent variable and t is the dependent variable, so which is equal to t into, so integrating factor we got it as secant cube x is equal to integral of integrating factor is secant cube x into sin x into cos square x. Okay, so here it is actually minus, I forgot to write it here, minus 3 here. So now here if you observe, this equation 5 is nothing but a linear differential equation in t. So as we know the procedure to solve the linear differential equation, so first of all we have to find its integrating factor. The integrating factor is nothing but given as e power of the coefficient of t, here what we have, so that is the minus 3 tan x we have, so e power minus 3 tan x means e power minus 3 into, so integral of tan x is nothing but log secant x, means e power log of secant power minus 3x means 1 by secant x we have. Now we will find out the general solution, and the general solution is nothing but given for equation 5 as t into, because t is the dependent variable, so t into integrating factor is equal to integral of integrating factor into what we have on the right side. So in the equation 5 we have on the right side sin x into cos square x, so that sin x into cos square x here you write once again. So now So if you simplify this t into integrating factor is secant power minus 3x is equal to integral of secant power minus 3x into sin x into cos square x dx. So now just you will simplify this. T by secant cube x is equal to integral of sin x into cos power, so 3 plus 2 5 cos power 5x dx. So this is what we get, and of course in the general solution here we have to write the integrating integral constant, or otherwise the arbitrary constant c also. We can continue like this. Now here just we have to evaluate this integral sin x into cos power 6x. Here we can directly write that formula by using a formula. So integral of f dash x into f of x, like that we can apply that formula directly, or otherwise if we don't remember that formula directly, then at least now we can take, so you just replace cos x is equal to some p you can write, okay. Then so we will get sin x dx is equal to minus sin x dx is equal to p, in the sense sin x dx is equal to minus dp, okay. So if you substitute that one, then we can write t by secant cube x is equal to integral of sin x dx can be written as minus dp, and cos power 5 can be written as p power 5. So p power 5 into sin x dx is nothing but minus dp plus c, that is nothing but the arbitrary constant we have, okay. Now we just simplify that. So which is equal to t by secant cube x is equal to, so minus of integral of p power 5 is nothing but p power 6 by 6 plus c, where c is nothing but an arbitrary constant, okay. So p means already we know that what is p, so this is t by secant cube x is equal to, p means here already we have taken as cos x, means minus cos power 6x divided by 6 plus c. So this is nothing but the general solution for the equation 5, but we need the solution for the given equation. So means now we will see what is t. So t here is nothing but we have taken it as some y cube. So this is what t we have from equation 3. So therefore now we will replace that t is equal to y cube in the final solution. Then here if we replace t by y cube, so then we will get y cube by secant cube x is equal to minus cos power 6x divided by 6 plus c. Here if you want you can write, since from equation 3 t is equal to y cube, okay. So finally this is nothing but whatever we got it here, so this is nothing but known as the general solution. If you want you can write it, which is the general solution of the given differential equation 1. So this is how we can solve the Bernoulli's differential equation. So once again let me explain from the beginning in the simplest manner. So whenever you observe any differential equation in the standard form, dy by dx plus p of x into y is equal to q of x into y power n, and when you can compare the given differential equation with this standard equation, there we can identify p of x is tan x and q of x is sin x into cos square x. Then to convert this one into linear, you just multiply with y square on both sides, and then here you replace this y cube with some t. Then this entire given equation now reduces or transforms to a first order linear differential equation in t, and later on we know how to solve a linear DE. Just we have to take the integrating factor as e power integral of the coefficient of t. Here what we have, we take it minus 3 tan x. Then after simplifying this, we got the integrating factor as 1 by secant cube x, And the general solution for that equation 5, which is linear in t, is nothing but given as t into integrating factor is equal to integral of integrating factor into sin x into cos square x dx plus c, where c is an arbitrary constant, and you substitute all the values, and if we simplify this, then finally we will get the general solution for the equation 5, and later on we have to replace t by a y cube, because that is a replacement in the beginning what we have taken. So by that we will find out the general solution for the given Bernoulli's differential equation. Thank you.